What's up guys, Steven here and welcome back to another video, and today we are talking again about the 5G apocalypse, hardware streetlight crime uncovered. So a very serious topic, and the last video I did put up on those 5G streetlights, oh man, that really blew up. I haven't received so many comments on the video in such a short time, absolutely crazy. A lot of you people are interested in this particular topic, so we are going to have a more in-depth look today. And also, I've received lots of positive feedback, but even much more negative feedback from people calling me an idiot, uneducated, liar, paid shill, sheep, whatever. I don't really care about all that. I just wanted to show you that what this guy is saying makes technically absolutely no sense. This is not 5G, and today in this video we'll also discuss my standpoint, my actually personal opinion about 5G. And I'm not a 5G supporter, just to clarify that in the beginning. I think it's the most overhyped topic in the telecoms industry, and also it needs proper research, but proper research with some real life scenarios and not with a guy that is taking some electronics apart, has no clue about it and just spreads bullshit. This guy is utilizing 5G for his own purpose. Either it's to make money or to promote his political party. I don't know what's his purpose, but this guy is not an anti-5G guy. It's just a guy who is using 5G as a tool of fear to trick you into something that is not true. And today, I want to clarify two things before we get started with this video. I'm not affiliated with any company that shows up in this video, so this is just for research purposes to show you the truth. Also, I'm not affiliated with this guy, Mr Steele. I just simply can't take his crap anymore. The videos he's putting out, it's really poisoning the people. And last but not least, this video is not a 5G promotion. I also have some concerns, which I will tell you at the end of this video. So please guys, don't comment before you haven't watched the whole video. I will not respond to any comments which are covered basically in this video. Alrighty guys, so now let's get started with this video. It's originally from that guy Mr Steele. He usually uploads videos on the channel of his brother for some reason because, well, he doesn't want that those videos get linked to him, which absolutely doesn't make any sense. If I make a video and I say, hey, I'm Steven and I upload it to my mom's channel, I'm still responsible for the shit I upload. Anyhow, so this video made it to another channel, it's Wireless Dangers Australia, and there we go, let's check it out.
Morning everybody. There's a lot of deception going on around this 5G, a lot of cover up by councils.
Lots of cover.
I put a post up the other day about a number of 5G transmitters on lights. They don't like that because it affects everybody. It's on all the street lighting, alright? Somebody at MI5 left the back door wide open. I'm going to explain it to everybody and why. Right, this is a potential ransom of the country on the back of this weaponry, because that's what 5G actually is.
Okay, let's assume this is true for now.
Increases the temperature. We're now starting to see a lot of councils, a lot of councillors, a lot of people in the councils being threatened, bullied and intimidated not to talk about it. So let's just do another breakdown. And obviously everybody's seen this piece of hardware from Harvard Technology. Right, this is Harvard. This is their hardware. All right, this is Harvard's technology hardware.
So it's hardware. Actually, this is just a switching power supply. So if you would have some knowledge, just name it. It is a power supply. That is nothing else. This box is a switching power supply. It's used to power the LEDs and the RF unit. I won't deny this. This is also giving power to the RF transmitter, but we'll just talk about that in a second.
And we've had this, you see the meat and potatoes piece here. Very heavy piece of equipment here.
Guys, power supplies are always heavy. Have a look in your computer from what you're posting right now probably. The power supply, it's an ATX power supply, probably that big, probably weighs around 1.5 kilograms. Absolutely normal.
See, this is then attached to this piece of equipment. This is a blatant weapon system.
Nope.
All right? It is not for switching the lights on and off.
So, well, this is not for switching the lights on and off. He's here correct, actually, but his intention is different. So it's not only for switching the lights on and off. You can remotely switch the lights on and off. You can watch my last video. We've actually seen the exact purpose of this. It's also for energy monitoring. For sure, there was a comment, LEDs have less power. Why do you need to monitor it? Well, it's just to see, actually get a track of all the energy you're using in order to tweak it. Second of all, also when something is wrong with the street light. For instance, if the street light fails, if one of the LED panels stops working from the 4 which are in there, it will actually generate an error code, and this error code is transmitted through that transmitter here to the base station, which links it then to the cloud, to the server, and the technician on the computer gets an alert on his computer. Oh, one of the LEDs is broken, please fix it. It's this part number, go to the storage, grab it and drive there. So this makes it maintenance very efficient. Right now, when a streetlight breaks down in my street, we are still very old school, I have to call the government agency, whoever is responsible for this crap, and just tell them, hey guys, the street light is broken, can you fix it? Then I have to wait for like up to 3-4 days until they come here and fix it. With that, actually, you also get the maintenance time down, because they get an alert, they already know what to do, they can order the spare part or grab it from the inventory and drive there and fix this. This is actually a very useful thing. For sure, it's not necessary, it would also work without it, but yeah, it makes life easier.
That says that it's deception, it is dishonest, it is actually an offence, all right?
Oh yeah, sorry.
This is the equipment that was fitted in Gateshead. This is 5G. It's a scanner.
First of all, this is not 5G. This is actually an open standard. It's very similar to Zigbee, so I can actually show you that. I've looked it up before. And there we go. Here we have it. Wireless Communication Systems. A really good book. So if you want to read it, make sure to check it out. So, well, as you can see, we have here Zigbee operates in the ISM radio bands, which are 868 MHz in Europe and 915 MHz in the USA. So Zigbee, you probably know that from smart home devices. It's operating at different frequencies. One of them is also 868 MHz. Some baby monitors, some of them use Zigbee. Many devices which you use at home, which communicate over some kind of RF technology, are using that frequency. So we have 868 in Europe, 915 in the USA, and these are actually exactly the frequencies this system is using to communicate. Now, there is 5G for lower frequencies as well. I can quickly show you that. 5G at lower frequencies, such as 700 MHz, is used to cover very long distances. So as you can see here in Germany, we're talking here about, I don't know, 60 kilometers or something. So here we have 40 kilometers, 20 kilometers. Yeah, it should be something like 63.8 kilometers, as you can see here at the top. Now, what is being used here? A frequency of 750 MHz to 758 MHz with a bandwidth of 5 MHz, later 10 MHz, so they're going to crank it up. But you need equipment that is putting out 5 to 7 kilowatts of transmitting power. This is a lot of power. This is 5,000 watts. And when we talk about Zigbee, then we are talking about milliwatts. So, for instance, what you have seen here, that is actually like 100 milliwatt of transmitting power. And as you can see, the range of such a small Zigbee module is, for instance, 10 to 20 meters and not 64 kilometers. So when you talk about frequencies, you also need to keep in mind which bandwidth are they using, which kind of transmission power. And what is being used here is not 5G. It's at a frequency which is an RF frequency. For sure it is RF, I won't deny that. But this is not 5G, and this is very important to understand. All right, so let's continue here.
This is the equipment that was fitted in Gateshead. This is 5G. It's a scanner.
It's a scanner,
guys. See the scanner?
See the scanner?
That thing on the end, it's got a dielectric lens.
So its camera quality is very crappy. I see that it is curved here and there is some kind of transparent thing on there which could act as a lens, but if you check out dielectric lenses, actually those are very complex systems. As you can see, it has here a lens which is focusing all the RF signals, as you can see, and then yeah, this to me doesn't really look like a dielectric lens antenna. Now, if you have some more experience on those, it looks for me much more like a normal GSM antenna. as you can see right over here, that is an antenna you can buy literally from China, from Alibaba for 30 cents. You can buy them in 100 pieces per lot, you can order 10,000 pieces, you can buy them on your own, 868 megahertz, 950 megahertz antenna. This is not a sophisticated equipment, this is really just a PCB with some layers on there and a coax cable. This is not a scanner. This is a 30-cent antenna. This guy has no clue what he's talking about.
Basically, a very, very sophisticated piece of target acquiring weaponry. All right. I know people will find that unbelievable, but what I'm going to explain to people, that there is a 450 volt capacitor. All right.
So he's always talking about the 450 volt capacitor, and this really makes him look like he has no knowledge about electronics. This guy is in no way a weapons expert. Now, this PCB board, it gets the 230 volts from those cables, as you can see from the faces, and well, it is operating at 230 volts. So when you have a little bit, just a tiny little bit of knowledge about engineering and electronics, you cannot put a capacitor on there which has less than 325 volts, something like that, because you have peaks in the voltage. It's using AC voltage. If you check this out right over here, electrical engineering board. So here you have the real engineers and not some weirdo with a screwdriver. So what you can see right over here, for 50 or 60 hertz AC, you have some DC peak values of the voltage RMS times the square root of 2, or about 1.4 times of this quoted value. So that means on 230 volts AC, what they're using in the UK as well, you expect more than about 325 volts peak over your lines. Choose at least a 400 volt or even better, a 450 volt capacitor. They even stated in the basic engineering guidelines, if you put there a 230 volt capacitor, it will probably blow up just after a few seconds. If you put a 10 volt capacitor on there, boom, smashes into your face. And it's unbelievable stupid. This guy has no idea what voltage is on this board. He cannot say that 450 volt, this is used to scan you or whatever. Absolute nonsense.
It is totally unnecessary on a piece of equipment.
We have just proven it's not unnecessary. It's actually necessary, otherwise that circuit is going to blow up.
Like this, look at all the chipsets, look at all the hardware, look at all the equipment, not as we're being told for switching lights on and off.
Yeah, it's for much, much more, but he doesn't even state that because I think he has no clue what this actually is.
The fabrication and a lie, all right? These are not light sensors. None of them are light sensors. This is a light sensor.
Yeah, now that's a light sensor. That's the only correct thing he probably said in this video. We'll check it out right now.
I want you to pay attention to this plug-and-play piece of equipment, because this is a light sensor. You can see it. There's the light sensors in there.
Now, pay attention to that thing in the middle. It's labeled with PD for photodiode 1. So this is the photodiode which is providing the voltage to the board. I will just explain what a photodiode is in a second.
Totally innocuous. And that has a 10 volt capacitor. See those little...
Oh, it got a 10 volt capacitor, and now this is safe. Well, now let me explain why this thing here has a 10 volt capacitor. First of all, this is from the company Lucy Sodion. It's the C cell, it's a photocell. A photocell already tells you it has something to do with light. That is why there is a photodiode on there. This board has almost no electronics because there is no RF technology integrated. That I agree. There is no RF technology, so this is really 100% not sending anything. It is just a light sensor. Now, the photodiode basically works with that principle. If, for instance, here there's a light source which, is sending some light to the photodiode, and the photodiode absorbs the light. And let's wait until this actually cranks up. As you can see, when there is light, the diode converts the light into a voltage. For sure, that voltage is nowhere near 230 volts. It's a very, very low voltage. And this is why there's only a 10 volt capacitor in there, because you don't need a 230 volt or 450 volt capacitor because you have a voltage from the photodiode which is way less below 10 volts. Alrighty guys, so why do you actually need voltage on that? As you can see, there's an orange box, and this is a relay. Now let me show you how a relay works. I found this on Wikipedia, sorry that I'm using the source, but it is a very good animation. So here you have a voltage generator on the left side, this is the photodiode. The photodiode is generating some voltage here to the relay, actually to the coil, and the coil is, when there is, when there's current running through the coil, it is generating a magnetic field, attracting the anchor. The anchor is on a lever, as you can see, and it closes the contacts of another circuit. Here, that light here, that thing, you can actually imagine as the LEDs of the street light. So actually, that light sensor works in the opposite way, because when there is light, there is a voltage. That means the sun is currently shining, and then you want that the LEDs are off. So when there's a voltage, you want that the anchor is opening the circuit. That means that the light is off. And when there is no voltage, you want that the relay is closed and the circuit is on and that the LEDs are on. So that's a very basic light sensor. It's very hard to explain it for me in English because it's not my native language, but I hope you got my point on how this works. So a very, very basic light sensor, and this is why you don't need a 450 volt capacitor on there.
Capacitors, 10 volts, that's all they are, all right? The capacitors on the 5G, 450 volts. I'm going to explain to people the difference. Here's a piece of equipment I had sent the other day, company called Telenza.
All right, so here we have the Telenza one, and it's actually the TCNME streetlight control. They have such weird names. It's from that company, Telenza, and here you can actually already see operational safety notices. So it has RF technology, and everyone knows that RF technology, when you consume really a lot, then it can be dangerous. The radio equipment described in this guide emits radio frequency. Although the power level is low, the concentrated energy from a directional antenna, so it basically says that there could be a directional antenna, may pose to health hazard. Only outdoor antennas are certified with this transmitter should be used and must be installed to provide a separation distance of at least 20 centimeters of all persons. That means you can only use that thing here with an outdoor antenna, which is not a directional focusing shooter antenna or whatever, and you need to mount it 20 centimeters away from all persons. When it's up on the street light, that's at least 6 or 8 meters, so it's at least out of the safety guidelines from the FCC. As you can see, this thing here is also FCC certified, so this can only be installed. So here you can see the radio transmitting power. We are talking here about 100 milliwatts of EIRP. I can actually show you what the FCC guidelines are for Wi-Fi. Here you can see this goes up to 1 watt of maximum power, not 100 milliwatts. So we're talking here about an EIRP in watts of 4 watts. That means your Wi-Fi router at home is the same danger as the streetlight. So when you're really concerned about the streetlights, I mean, I get it, it's a lot of RF everywhere. But then also, please, remove the Wi-Fi from your home. Remove any smart home devices. Then you really need to have a very, very basic home. I'm totally okay if you say RF is bad, but then also don't blame it only on the streetlights. Kill your Wi-Fi router. Don't ever switch it on. Don't use a smartphone. That is all producing EMF and RF frequency. And also, what is also producing EMF? This is something most people don't know, but it is actually true. Let me show you that. So guys, here you can see it, a hairdryer. Yes, a hairdryer. Basically, every electronic device is producing an electromagnetic field. So if you're EMF sensitive, I think it is true. I think some people can feel that. It's something I really understand. I'm personally not EMF sensitive because I have a lot of electronics here. I feel good, but there are people who probably don't feel good for some reason. So it's still being studied. I don't know how this can occur, but then as you can see, a hairdryer has an electric field strength of 40 volts per meter. This guy also runs around with an EMF meter and he's claiming he's measuring 5G, but this is complete bullshit. If you use an EMF meter like that one here, this is a broadband spectrometer. I hope I said this correctly. That means it is actually detecting all frequencies from, I think this has a range from 20 megahertz to 2.5 gigahertz or something. Some go even from 20 megahertz to 50 megahertz to 3.5 gigahertz, and it's detecting everything. So the sum of all EMFs in that area. That means if you are near to any device with a lot of electrical power, like a train, he also used it in a train, it's picking up the EMF from the electric motors in the train, from basically from all the power lines. And this is not 5G, he's just talking crap. For sure it's EMF, and I do understand people are EMF sensitive, but then you cannot also ride on a train, you cannot use Wi-Fi, you cannot have any electrical devices near you. You need to understand that. You cannot mix this up with 5G. Alright, so let's go back to the video and let's watch a little bit further.
See the plug and play? Because it can easily be changed. So this one, you can swap it out with this one in a heartbeat. So that's the light sensor, and that can be replaced pretty quickly with this piece of equipment. All right, let me just show you what's in here. This is the bottom end.
So the bottom end, you've seen those contacts, they're actually plastic, they go directly from the mains to the board, so they're supplying the board with 230 volts of power, of voltage.
We're going to take off.
Yeah, that's the operating
this
voltage
is to
of
look
the electronic
inside.
circuitry inside.
Right, and that thing there is a nice bit of hardware. All right, you see it? Well, not nice. It's nice if you're going to try and pull a weapon system on somebody. Those capacitors, 450 volts.
Once again, they need 450 volts because the circuitry is operating at 230 volts. I'm not discussing this anymore. This is done. This is bullshit. Facts, hands down. He's talking
Just
crap.
throw it out. This is a dipole antenna.
Honestly, this is a single via antenna. This is not a dipole. Where's the dipole? A dipole antenna has a T-shape. This is how a dipole antenna looks like. I can show you. Dipole antenna. As you can see right over here, here you can see it. Here is the entry, a pole right over here, a pole right over there. You can even look this up on Wikipedia how a dipole antenna looks like. Here, you can see it. 2 poles. You can actually have them in different angles, whatever you prefer. Antenna designs are very complex. This is a single via antenna. And coming to that, I'll actually quickly show you how a single via antenna and how those things work. For optimum operation, the antenna length must be related to the wavelength of the signal. Common antenna sizes are 1/4 or 1/2 wavelength at the operating frequency. The higher the frequency, the shorter must be the antenna, not the longer. The shorter must be the antenna. We can actually verify that right over here. If we check this out, frequency of we have between 800 and 900 megahertz, so the antenna must be between 8.3 and 9.4 centimeters. So something like that. And this is actually exactly the wire he shows in this video. This is a single wire antenna for this frequency, which is not a 5G frequency. This guy is talking so much crap, unbelievable.
It radiates in all directions.
Radiates in all directions. Well, this is not a dipole antenna, this is a single wire antenna with that plastic thing here giving it up some other capabilities.
Sophisticated. Look at the hardware. Look at the chipsets.
So look at the chipsets, yeah. Everything has chipsets. You can look in most of the electronic things inside, you will see at least a single IC in there. And he's not saying anything about the chipsets. If he would actually want to show you something, he would tell you, hey, this is this chipset with this number, go look it up at Google, it's doing that and that. But he's just with a potato camera showing you some chips on a PCB that absolutely have nothing to do with 5G.
I'm going to let you have another look at this light sensor to show you these are not light sensors. All right? That thing there on the bottom, 3,300 watts. That will cook you alive.
Oh
all right, 3,000.
God! So this is the ultimate proof he's just talking crap. Now 3,300 watts. Sorry guys, I'm just so pissed. This is basically the maximum power this relay can handle. It's not outputting that power. Some people even pointed it out in the comments. So we have some actually smart people in there. Maybe not that smart because they actually said, as you can see, this is a capacitor. This is not a capacitor. This is actually a relay. Now we have talked before what a relay is, and I've actually looked up exactly that relay. So let me quickly find that here. So guys, I've just found the relay. You can buy that relay for around €5 in your local electronics store. This is a very basic relay. So guys, here we have the data sheet of that thing. It's not outputting 3,300 watts. This is a latching relay. And as you can also see right over here, the maximum switching power So basically you can imagine that as an electronical switch. It's 4000 volt amps, or in this case of this relay, which is slightly different, 3300 watts. So 4 kilowatts around, something like that, is something you can control with that relay. We had before what a relay actually is. It's just a simple switch, if you want to name it like that, which is controlled by the circuitry. But this is nothing that outputs 3300 watts. So this guy is really talking so much nonsense here.
1,300 watts. That will cook you alive. All right, 3,300 watts, very powerful piece of equipment, right? That's been swapped out for this, all right? So sometimes the masqueraders, they fit these, and then they come along late at night. This is a light sensor. Come along late at night, plug and play, and they change it for this, basically, piece of weaponry.
Oh my God, I'm gonna die.
Right? Now that's not the most dangerous, because this isn't a target acquiring piece of weaponry. All right, this is for something else. This bit is target acquiring. All right, that sensor on the end, this scanner, it's the bit they don't like people to look at. That's got a dielectric lens at the end.
So you can see it better. Actually, I still don't see the dielectric lens. He's just, man, I have no clue what to say. The first one is a single wire antenna, very basic one, and the other one is one on a PCB, but there's nothing wrong. You've seen you can buy those things for 30 cents in China.
Right, very, very dangerous piece of equipment. Now, what's happened, we've actually had sent to us another piece of equipment, right, where they've actually removed the interesting bit. So this is the same company, but look, I'm going to show you. See, they've removed the nasty bit, because obviously a bit obvious that to anybody that knows about dielectric lenses and weaponry. So you can see how that's been cut away. They've actually removed this. This has been ground away, right? But this is an illegal scanner, so you can scan into your home. Look at the hardware. Once again, 450 volt capacitor. Right, where it can actually be used. Look at the chip.
So sick. Look at the chip.
Look at the equipment inside and outside. Not a light sensor. This is 5G, by the way, and this is the same company, Harvard Technology.
That's
the company 5G, there. Dude. All right, they have went into administration. Your local authorities are telling you it's a bona fide company. Queen's Award for Industry. Basically, it's went bankrupt. And the reason it's went bankrupt is because somebody's covering up the crime that they've tried to commit on the people. Right? I had one of these sent to me the other day. This one's had a bit of hammer.
So while he's just showing different hardware all the time, and once again, you can see a different antenna design, but basically it's this very similar unit, such this node here. I quickly want to show you something that is also interesting in this video, and this is where he talks about the antenna length right over here.
You can see that it's been taken away specifically, it's been ground away, right, so that the evidence is actually being taken away, all right? But what I'm going to say to people, right, who's sanctioning the trolls at GCHQ to shut down the 5G cause anything over this antenna and this one's absolutely blatant, by the way. That's why they're changing this. They've changed this specifically because anybody knows that this is a scanner. It's a target acquiring scanner antenna. This is the scanning bit and this is the shooty bit at the end. All right, that allows.
So he says that is the scanning bit and the other is a shooty bit. It's just acting like a kid here with no knowledge of what he's talking about. So once again, if we actually check out here the antenna guidelines, then if you shorten the antenna, you're moving here into higher frequencies. For sure, antenna designs are very complex, but just in general. So actually we're right now at something like 4 centimeters, would be a little bit higher frequency, still something in the ISM or Wi-Fi standards. And I don't know what he's trying to do here. You can actually watch the whole video for yourself. We covered now the most important parts, and the other parts is just repeating itself. The government is doing that 450 volt capacitor, blah, blah, blah. So what I just want to say here, those streetlights are not 5G. And now we come to the real point of 5G. So I think 5G is really the most overhyped topic in the whole industry. So we are so far away from those weird white papers they gave out, up to 300 gigahertz. They don't even know right now what they want to do with those 300 gigahertz. Nobody knows. Also, when you talk about 60 gigahertz, well, 60 gigahertz, it is running nowhere. There is millimeter wave running right now with around 24 to 28 gigahertz, so very far away from the oxygen absorbing, vibrating thing which people say. So we're not using 60 gigahertz in any country right now, just to clarify that. Most countries use sub 6 gigahertz 5G standards right now, which is still RF technology. Those frequencies are already kind of well studied, but we don't know what happens when we densify the antennas. You will have much more antennas in general, which is first of all a good thing, because a smartphone has also transmitting power, and when a smartphone has a bad signal, so when the cell phone tower is very far away, the smartphone really cranks up its transmission power and it's outputting kind of a lot. This is called the SAR value. So there are safety limits for smartphones, and also personally I don't keep my smartphone all time at my body. So also at night I turn it into airplane mode when I sleep, just use it for the alarm clock. So I also think about those things, but seriously, when you have more towers, it would actually reduce the power from your smartphone where you're near at. And this could be a good thing. It could be a bad thing still though, because you have more RF in the air. When you're running around, you always get 2 RF signals. And we need more studies on that one. I totally agree with that. What he's putting out here, that are not studies about 5G, is just trying to panic about 5G and to confuse you guys. Also, regarding millimeter waves, as I've told you, most countries are not using millimeter wave yet. In the USA, a few countries are using that. So I would like to see some real-life studies in those countries where this is being used right now. No millimeter wave in the UK, so as far as I know. And we need studies with real-life parameters. There have been studies from the Russians in World War II, and you have basically linked me all that shit, but we are talking here about really scary things, and I can show you here some PDFs I've found. So we have looked at that PDF before. So it's using a 5 kilowatt equipment or 7 kilowatt equipment to basically transfer the signal here over 64 kilometers. Now, it's only interesting when you talk about power numbers, because they really tell you how strong the transmitter is. So we have 5 kilowatts for that 5G signal. But who is talking about televisions? Did you know that televisions, as you can see, DVB-T transmit power 100 kilowatts ERP per carrier? And this is a real scary thing. I mean, even at the old analog TV stations, you could really roast the sausage in front of it. And that are really high powers. Nobody's talking about television signals. Everybody's talking about 5G with very low signal transmitting power. But who is talking about real RF bombers like television signals? Nobody. And I want to actually have some more studies on, first of all, transmission power on lower frequencies, which is very interesting, and also studies on high frequency, low transmission power. Because usually what's dangerous is when you're next to antenna, because there you have the really high transmission power and it has a safety field around it. That means in the safety area, you're only allowed when you switch off the antenna. You don't want to climb a base station which is running unless you want to kill yourself. This is also dangerous for workers. In the safety guidelines, I've talked to several workers. They have to shut off the base station until they can go up there and change cables or change modules. So it's really, really important to talk about transmission power. And I'm pro studies. I really want scientific studies, but I don't want a guy that is utilizing 5G as a tool to promote himself, to raise money, and to do some other weird things and just scare people. We need real scientific studies with real life scenarios, and not studies which are people linking where they use 100 kilowatts, 10 kilowatts to roast little rats. For sure this is dangerous. Everyone knows this is dangerous. This is why in the safety guidelines it says, shut off the tower before you can climb it, because it's dangerous. Same if you stand in front of a radar on a ship. You shouldn't do that. This is dangerous. We all know that. But you always need to keep in mind transmission power. And this is very important. So in order to have a closer look at that, I got myself a Hack RF. That's a really cool thing. It can actually measure and replay signals between 1 and 6 gigahertz. Now, I also have a custom antenna for this and some other things. This will be in my next video. I'll really go to a 5G tower and measure the transmission power in dBm, and also check out the electromagnetic fields there, electromagnetic fields in the wood next to electrical equipment. I really want to show you some real-life scenarios of all that and don't make you panic over all this. But I do agree it needs more science on that topic, but real science and not bullshit. Also, something you guys probably don't know, electric cars. They are using radar systems, as you can see right over here, and they're using it at really high frequencies, so-called ultrasonic sensors. So you can find this somewhere here in the PDF. For instance, here, it also has a millimeter wave radar in the front. So this is a Tesla Model S, and the thing you can see in the front, this is using millimeter waves. And there you can see it. So a Tesla Model 3 has, for instance, a millimeter wave radar. So this is something that is really already on the road. And here you can see the frequency bands. It's using 24 gigahertz, which is used for 5G right now, and 76 to 77 gigahertz. So a really, really high frequency. Nobody's talking about that. They all talk about 5G, which is right now running at sub 6 gigahertz. So you should also have a look at those things before you just freak out. Alright, so that's just regarding the technical bullshit he's spreading and about my standpoint about 5G. I hope you guys now got it. But who is actually Mark Steele? So I looked this guy up on LinkedIn, and he's actually promoting a company, he's still working for a company that is called Revo. So also on Twitter, he still has this link in his bio, so people can click on there, check it out. He's still posting stuff about 5G, virus, blah, 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 so some very weird language. But actually, what is Revo? And if you don't believe that this is Mark Steele, I will just show you that he is it. So here you can actually see a picture from him where he doesn't wear his weird glasses he's now utilizing in his videos. Actually, in 2012, I think those LED streetlights got installed in most of the countries, including the UK. And he claims to be a weapons expert forever, so he knows already about all those LED stuff. So why is he not wearing his glasses here right now? So when he already knew about all that crap. So he's working for Revo since, I think, 2012. You can look all that up on LinkedIn, as you can see, since 2012. So it seems that he's just using the glasses right now for his videos to make it look more, more true. Alright, then what is Revo? So Revo is designing motorcycle helmets. This is not an advertising for the company. I really don't know the company. I just looked it up right now and I don't know about anything about the products. So it says that they have a rear view monitoring system which works with fiber, optic, bending the light, whatever. I don't know how it works because I haven't checked it out. Maybe some mirrors. And as you can see, it comes with an inbuilt GPS system. So at least they claim it here. So I'm not sure if that's actually from the company, but GPS frequency is actually also an RF frequency, as you can see right over here. So do you want to have that in your head? I don't know, me not. Then here we can see the gaming headset without the headache. Okay, so they claim as a gaming headset which doesn't cause you any headache. But if you're EMF sensitive, why do you want to have an EMF emitting device behind your head? This makes no sense to me. So why is he promoting that company which is working on such things? This is a helmet where you put your smartphone or gaming device right next to your head for a couple of hours maybe when you're playing that. And here's surround sound, that probably works via Bluetooth, so you have a lot of RF frequencies directly in your head. I don't get it. Why is a company promoting such things? Why is he working? Why is he against 5G and working for such a company? I cannot believe that. Then here we have ways to protect yourself from electromagnetic fields. Avoid using Bluetooth. Avoid living close to power lines because they also have EMFs, as we have seen before, hair dryers, everything. So don't only think about 5G, think about everything else. For sure, 5G will have more densification. That's absolutely true, but we need some real-world studies with those transmitting powers at those levels. So guys, I really hope you got my point right now. I'm not a 5G promoter, nor I'm against 5G. I'm just here, I think 5G can be useful in the future, but 5G must also be safe. But in order to study that well, we need to have proper studies and not some random guys with no technical knowledge taking apart things they don't know what it is. And Yeah, sorry that this thing got me mad, but in the last video, people just simply didn't understand my message. I hope it's clear right now, clear for some reason. I will try to make a more scientific video with my measuring equipment. Should get it at the end of this week, then I have to build the antenna, already have some designs. If you're good with RF frequencies, get in touch with me, would be really amazing. I need some help. I'm also on Reddit studying this a little bit more. And yeah, let's see what numbers we actually get from a real 5G tower. Very curious about that, very, very curious. Okay, that's it. Video, as I've told you before, not sponsored by any company, not sponsored by those Revo guys or whatever. I don't know the products, I don't know if they're good or not. Just this is for legal purposes. I'm not affiliated with this Mr Steele guy. I really just don't like this guy. Alrighty guys, so big thanks for watching this video. As always, stay safe. I'm Steven from Tech Magnet and I'm signing out. Bye.